Okay, so this is a talk about a brand new experiment that I've been working on where I'm taking these two libraries, Cats and Circe, and porting them from Scala 2 to Dotty, which is a research compiler and a language that's being developed at EPFL that will eventually become Scala 3. So before we get started, how many people in here use Cats? Okay, wow, almost everyone. And how many people use Circe? Okay, wow, almost everyone as well. Okay, so I won't really introduce these projects since it seems like almost everybody has used them. So Cats, these are some fundamental abstractions for functional programming in Scala, and then Circe is JSON encoding and decoding. And if you haven't seen these projects, I'd encourage you to take a look at them. We use them extensively here at Permutive and many, many other organizations. One just kind of fun fact that I remembered this morning is that I thought, oh, it's getting pretty close to Circe's birthday. So Circe started as a fork of Argonaut, and the very first commit was August 1st, 4 years ago. So tomorrow will be the fourth birthday of Circe. And I'm really hoping that, that this July will be the first month that we hit 2 million downloads. So we've been hitting about 1.8 million, a little more over the past couple of months. So this might be the first month that we have 2 million downloads for the Circe organization. So I think that's pretty exciting to get that far in 4 years. Okay, so I'll warn everyone that I am not an expert in Dotty by any means, that before 2 weeks ago, I'd never written a line of Dotty. I had seen a couple of talks, but that was it. I knew absolutely nothing about Dotty. So this is more of a kind of experience report of my attempt to take these two libraries, move them to Dotty, and start porting specific things over to Dotty features. I would encourage you to, if you're interested, take a look at the Dotty documentation, that there's a really good high-level motivation for a lot of the changes that we'll be looking at here. So the second link is to these slides. So if you want to look up any of the links here afterwards, I will be tweeting that link out. And then this third link is a brand new project that I just opened a few minutes ago. So this is the repository that contains these two libraries. So what I've done is I've taken the Cats repository, moved in the Circe repository, and then I've gradually been moving individual pieces of code into Dotty-specific modules and gradually making them Dotty idiomatic and porting over things like macros and generic derivation. So we'll be looking at this repository as we go through the talk. Okay, and one thing I did want to note is that you don't actually, this work that I'm doing on this port, it's not because I want to be able to use Circe or Cats from Dotty. So you can do that right now. Like, one of the really cool features in Dotty is that the compiler knows how to understand Scala 2 bytecode and Scala 2 artifacts. So you can just drop in these vanilla Scala 2.12 coordinates into your SBT build if you have Dotty set up, and then add this Dotty compat modifier, and they'll just work. So the only things that won't work, that Dotty can't understand, are macros. But if you're working with Cats and Circe, that means you don't get some nice function case syntax and you don't get generic derivation, but almost everything else should work right out of the box. And I do have in this repository, there's a compat directory, and in that directory there is a build setup. This is separate from the rest of the repository, just where you can go in and use these original 2.12 artifacts from Dotty, not the port, just the original artifacts as they're published on Maven Central right now. Okay, so the goal of this port is more to experiment with applying language features in these libraries than it is to make these libraries available on Dotty. So as a kind of an outline of some of the features and topics we'll be looking at, So I want to start by looking at this change to the implicit mechanisms between Scala 2 and Dotty, because this is one of the biggest changes that we'll see in Scala 3. I'll briefly talk about this experiment that I've been doing in cats to get rid of a lot of these instances that are orphaned, and we'll talk about what that means as a kind of way to make it more in line with the principles of Dotty. We'll look at the new generic derivation system in Dotty. So previously in Scala 2, libraries like Circe provide this way of automatically generating type class instances for your case classes. That's mostly supported by macros, by libraries. A lot of this functionality is moving into the compiler and into the standard library. We'll look at one macro that I've ported to the new Dotty macro system, and then some opaque types. And then I'll wrap up by just, so there are a lot of features that you may have heard about in Dotty that are not on this list, and that's usually because I tried to apply them to some specific area that I knew about in cats, and I ran into bugs, or I ran into things that I just didn't understand and couldn't figure out from asking people or the documentation. So things like unions and enumerations, we'll talk about some of the issues that I ran into. Okay, so I want to just talk a little bit about the kind of philosophical differences between Scala 2 and Dotty. So Scala 2 is made up, it has a range of language features that they're general purpose, but they're compositional. So the idea is that you take something like implicit, you combine it with other language features to produce different kinds of techniques that can be turned into patterns. And the fact that there is this fairly small set of language features that then can be combined into more complex constructions, that's led to this kind of meme that you might have seen where Scala advocates will say that Scala is actually a very simple language because it has a spec that's less than 200 pages, where the Java spec, for example, is 700 pages. I think this is actually just completely wrong. So this is from Twitter, that because of one of the goals of Scala 2 and something that's very fundamental to the philosophy of Scala 2 is this idea that you have all of these language features that you can combine to build much more rich constructions. And so you do get this kind of combinatorial explosion of things you can do with the language. That means that even though it's a much shorter spec, if you look at the Java spec, you're going to have language features that are not designed to be composed in the same way. So it's actually a simpler experience and I think that accords with most people's experience of working in Scala 2. This is something that personally I've always really loved about Scala, this fact that it gives you all of these building blocks, and then you can do incredibly complex things. So I have a blog post about this kind of very bizarre way of building what essentially looks like multiple implicit parameter sections in Scala using like 6 different weird language features. And it's just this idea that's really central to Scala 2, that you can take simple language features and turn them into something much more complex. And this is just one example that I talk about in that blog post. So this quotation here is from an issue that I opened as a compiler bug in 2012. So I was running into problems with with these type lambdas, which are a way of partially applying a type inline, which you needed to do before we had this nice kind projector plugin. So I was running into problems using these type lambdas, and so I opened an issue, and Paul Phillips, who's one of the compiler developers, responded and said, actually, we never wrote a line of code with these type lambdas in mind. So this is something that was just invented by the community. It's this whole little piece of syntax that is just built by compositionally taking type refinements and type aliases, putting them together, and essentially building a new language feature. And I think that's really, there's something really compelling about that. Also, the problem is that if you do build up these complex features out of simple features, you can often like multiply any kinds of weird edge cases or problems. So in this case, like type lambdas work 85% of the time really nicely, and then they break down in a bunch of corner cases because the compiler and the language isn't designed for these things. That these are kind of accidents or community creations. Okay, so what you will see over and over again in Dotty is that we're moving away from this idea of just taking a bunch of general purpose language mechanisms that can be composed into a language and a compiler that supports a specific set of patterns. So the Dotty team is looking at what the community has done over the last 15 or whatever years in Scala, identifying patterns that are useful, that are effective, and then turning those into dedicated language features. And then gradually, over the life of Scala 3, some of these general purpose mechanisms will be dropped. So in Dotty right now, you can no longer use the Scala 2 macro system. So that's the one thing that if you're depending on Scala 2 artifacts, you don't get. And then I believe in Scala 3, you will still, 3.0, you'll be able to use implicits along with the new Dotty version of implicits, but then in 3.1 that will be dropped. And then there's a kind of life cycle for as we bring in these new dedicated language features and phase out these old general purpose language features. Okay, so this is a quick quiz. Can anybody see, can everybody read this? These are all things that you can do in Scala 2 right now. In my experience, 6 of these are things that you see fairly regularly. 1 of them is not. Can anybody pick out the one that is not common or doesn't really make sense? The third? Yes. Yeah. So the rest of these essentially correspond to what became patterns in the community in Scala usage. This one just doesn't really make any sense though. So the first one would be something like an implicit conversion, that I have a rich string type. I want my users to be able to use strings as if they were rich strings. And so I have an implicit method that takes one non-implicit argument. So this is really common. This is this kind of implicit conversion. The second one might be an implicit conversion, but one that's driven by a type class. So you have both a non-implicit and an implicit argument. This one, though, you can't have, the compiler won't automatically apply the implicit method if you have multiple arguments, so it doesn't really make sense in the same way. But then I was thinking about it, and you could actually, it's not exactly the same as if it weren't implicit, because you could have a method that requires an implicit function with a function 2, and the compiler would lift this implicit method into a function to supply it in that case. So it's not actually exactly the same as if it wasn't implicit, but it's still, I've never seen this in real Scala code, but it's probably been done, and you can do it. And then the rest of these are just this one, an implicit method with multiple implicit arguments. This might be something like a generic type class instance. But the point is that these are just, what we've done is just basically taken our methods, and if there's a slot for implicit or not implicit, we can try all the combinations of these things. And they're all valid Scala, and some of them become patterns in the community. And some of them just kind of don't make sense and aren't used very often. So that's implicits in Scala 2. In Scala 3, this is like all out the window. We no longer have implicits. Now we have these things called givens. And when I first, when I first started looking at this 2 weeks ago, my timing was pretty good because I just missed this long, horrible bike shedding about whether these things should be called givens or delegates, I think. And then before that, there were other names for it. So there's a lot of fighting about as we go from implicits to what's going to replace implicits. And I landed right after we settled on givens. So givens are this idea of given language constructions. This is a move away from just throw implicit anywhere, and maybe it will make sense, maybe it will be useful, and maybe it'll just be something weird. Now we have a new keyword, a new syntax that doesn't look at all like ordinary method definitions. So this is what if we are defining an instance of a monoid type class for something like option. So this is a generic instance of a monoid. If we're defining it for option, we need to have a semigroup instance for the element type. In Scala 2, that's just a method definition. It's just an ordinary method where we dropped implicit in some certain places, and the community has decided that this is the best way to represent type classes in Scala 2. In Dotty, it's completely different. This doesn't look at all like an ordinary method definition. So here we have this new syntax that says we give this instance a name. This is the most important part. This is what's saying this is the type of this instance that I'm defining. It is a monoid of option A, and then I have a requirement. So this is like the implicit argument section. I have to have an instance of a semigroup for the element type. The other thing that is really, really nice here when you're actually working with these things is I no longer, because I'm not just building this on top of ordinary method syntax, I don't have to write out all of this constructor business down here. So if this type, the type of my instance, is a class type, I can just implement the members of that class in the body. So this is dedicated syntax for defining type class instances, as opposed to just kind of building type class instance definitions on top of existing method syntax. And I've converted like a bunch of these, some of them semi-automatedly, some of them just by hand, and it's actually really nice. Like it makes your code cleaner, it makes your code more readable. The syntax looks kind of weird at first, but you get used to it very, very quickly. And I just find it a much nicer experience to navigate around the code base when you have these things instead of these things. But you look at this, and if you're not sure, you might not know which of those many different kinds of implicit combinations it is. You have to do this kind of search for where the implicits are sitting, where this is just clearly a type class instance. Okay, there's also a new keyword, or not keyword, a new method in predef that allows you to pick out the type class instance if it exists. So instead of implicitly in Scala 2, you have this new the. It's non-widening, which maybe if we have time in a bit, we can talk about what that means. But I realized a couple of days ago that, so this is a tweet from 2014 where I'm trying to convince Miles that the is the right name for this method. So if you hate it, I'm partly responsible for pushing through the. I kind of hate it too now, but it's at least partly my fault. But yeah, so the lets you pick out the instance of the type. And now this is my very favorite part that has made such a big difference in my experience of working in Cats. So does anybody see the difference here between this and the previous definition? There's no name. Where are there no names? There are two differences. Right.
The semi-group doesn't have type, like a value.
Right. Right. So I don't have to name my instance, and I don't have to name my requirements. So in Scala 2, you just have all of this boilerplate because you have to. I mean, this is a little bit like the type constraint, like the constraints on types in Scala 2, which is still valid syntax in Scala 3, but it's just a more complete anonymous experience that you don't have to give these things names. Okay, yeah, so that's the version with the names. And so I know that this is kind of my own problem that I need to deal with, but in Cats, there are hundreds of type class instances, and the naming conventions for them, we have naming conventions, but they're not enforced in any way, and they're massively inconsistent. So if you dig around in the Cats code base, you'll see like 4 different versions of naming conventions that are used in multiple places, and then lots of naming conventions that are just not followed, like just random stuff, like kernel instances in core, or core instances in kernel. Some of them have standard in the name and some of them don't. I know most people don't care, but this really bothers me. That yes.
What error message do you get if you have a diverging implicit? Right now it tells you have this instance name.
Yeah, we can look at some examples. So you do get a much nicer errors, and well, they're nicer up to the point that they do include the synthetic names, so that you do have to, at least at this point. This might change at some point. It seems like the way the synthetic names are produced is subject to change. Yeah, okay. This is another weird piece of syntax that's, so instead of having implicit classes that allow us to add enrichment methods to whatever types we want, now we have this, this syntax where it's kind of weird looking that the first argument section is just moved ahead of the method name next to the def. But again, it's the same general principle. Instead of taking implicit classes and using them to build add enrichment methods to types, we have this dedicated extension method syntax. And does anybody else notice something weird here that's not in Scala 2? I'm sorry? Yes, yes. So this is another big, big part of it, that in Dotty, you can no longer import both ordinary values and implicit values with a single import. That import, if I didn't have the given here, I would just get any values that happen to be defined in this package, and with the given, I get given values. So again, it's this idea that implicits are special, that these are things that live in their own space. These are things that are used for particular purposes like extension methods or like type class instances. They're not just ordinary instances that have this keyword and some semantics slapped on them. Okay. So, so one of the big changes, I'd encourage you to take a look at the documentation for the project, which goes through some of the more detailed changes that I've done. But one of the changes that that I've made is, so Dotty, one of the, if you look through the official documentation that talks about the motivations, they list a number of critiques of implicits in Scala 2 that they're trying to address. And one of them is this kind of overuse of implicit imports, that it's really hard to reason about implicit imports, that they're often overused in Scala. And so one of the things I wanted to do to make cats more idiomatically Dotty-like is to reduce the number of times that a user of the library needs to import implicit definitions. And because in the interest of time, I'll go through this a little bit more quickly. But the idea is that in cats, we have a lot of, in any programming language that implements, that uses type classes, often there's this distinction between orphan instances and non-orphan instances. And in Scala, this plays out in the way that Scala looks for implicit values. So it will first look in implicit scope, or in lexical scope, which is implicit definitions that you've defined in the current scope or that you've imported. And then it will look at implicit scope, which is going to be, for a type class instance, the companion objects of both the type class. So if we're looking for a monoid entry, after it looks in a monoid for the entry type, after it looks in lexical scope, it will go to implicit scope and look in the companion object for monoid, and then in the companion object for entry. And that implicit scope requires no imports. So this is a place where you can avoid requiring implicit imports by moving every type class instance you can into either the companion object of either the type class or the target type, the type that's being characterized. Okay, there's a lot of debates about whether orphan instances are good. So some languages prohibit them entirely. Some languages discourage their use. In cats, they're used for all standard library types. So if something like the monoid instance for integers, or the traverse instance for list, all of these instances, they could be defined because we control, as the cats library authors at this moment, we control the the companion objects of these type classes, but instead they're defined in packages that then have to be imported because they're not part of this implicit scope. But that's not, this is separate from the kind of more philosophical arguments about whether orphan instances are good or not. So this is just a kind of mechanical problem with the way implicits are resolved in Scala. And I'll skip through this pretty quickly. So the difficulty is that if let's look at this. So list has a traverse instance. That if I define that traverse instance in the traverse companion object, then if I ask for a functor of list, I'm not going to get it. Because when I'm looking for, if I'm trying to resolve a functor list, I'm going to look in the companion object for functor, and then for all of the supertypes of functor. So I'll look here, but I've defined that traverse of list in traverse. So I'm not going to go down and look there. So that means that I can't really, without some extra mechanisms, define that instance in traverse. I can define it in invariant. I can because then if I ask for a traverse of list, I will look up the tree and hit it in invariant. If I ask for a functor, I'll look up the tree and hit it in invariant. But then the complication is that you have multiple roots to some of these type class trees. So traverse has these diverging parents. So I have to define it both here and here, or define it here and alias it over here. And then I have to cut up this space in such a way that I can find the proper instances when I ask for these type classes. And this is something that I've always wanted to do. I've always wanted to try and see if this was possible in Scala Z or Cats, because it's something that's bothered me for the last 10 years, that you have to import the type class instances for something in the standard library when they could be defined in implicit scope. And it turns out it's actually really easy. And I don't think that anything that I'm relying on right now is Dotty specific. So I started making this change as a way to minimize the number of implicit imports that I'm forcing on my users as a kind of way of adhering more closely to the Dotty philosophy. But it turns out that I'm pretty sure, I don't think I've run into any serious problems, and I have quite a few of the tests ported over. And I've tried a lot of different things. And it seems like the approach that I've taken to moving these instances into implicit scope just works pretty well. So I'll probably try to propose this for Cats 3 to move these instances into implicit scope so that you don't require the Cats instance import anymore. But I don't know if anybody else cares enough about that for me to be able to push it through. OK. How are we on time? All right, so how many people have used generic derivation in Circe or another library? OK. So I won't spend a lot of time with the motivation, but the basic idea is if you're writing boilerplate like this for all of your type class instances, it's really liable. You're likely to make errors at some point. That either you'll change a name in the type class instance and think that should be reflected in your serialization, and then run into problems because you haven't changed the name in multiple places. Or there are other ways of these things getting out of sync but still compiling and then leading to weird, unexpected issues. So the idea behind generic derivation is instead of writing these mechanical instances for all of your case classes, you just have some way of deriving an instance, of asking the compiler to look at the structure of your data types and to build an instance automatically given the structure of your data types. So in Scala 2, this is most implementations of this are powered by the shapeless library. So shapeless provides generic representations in the form of H-lists and coproducts that lets you take your case classes and your ADTs and map them over to this generic representation, and then use the generic derivation that provided by the library that you're using to build those type class instances automatically. This actually it gets a lot more complicated than it sounds. That if you want to allow users to modify the instances, there are lots of ways you can do that. There are lots of problems you can run into. It can be extremely slow at compile time. So there are like, at least right now, at least four completely different ways of doing generic derivation in Circe, because each of them has different trade-offs, and some people need faster compile times versus more rich features. Some people need really detailed configuration, really detailed transformations that happen during generic derivation. So it's kind of, I have a talk about this from Scala World a couple of years ago, where I just talk about all the things that are really frustrating me about trying to implement generic derivation in a generally useful way in Circe. Okay, in Dotty, all of this work that's being done by Shapeless and by individual library authors is being moved into the compiler and into the standard library. Or not all this work, but the kind of patterns that are proven generally useful. So now, has anybody seen this kind of syntax in a language like Rust or Haskell, where, yeah, okay. So in the definition of your data type, you can just say, I want to derive order instances or encoder instances for this type class. And this is code that will work in this port right now. So I've implemented generic derivation for just a handful of type classes, like order, monoid, the Circe encoders and decoders. So when you define your case class or your ADT, so you can't derive at this point a monoid for an ADT because it's not really clear what that should mean in the general case, but you can define an ordering, you can define an encoder, and you can do all of them for case classes. Okay, so let's see. And this looks a little bit like, so if you've used the macro annotations from Circe or other libraries, these allow you to put a kind of annotation at the front of your definition that says, also please derive a Circe decoder and encoder for this. The problem with macro annotations is that many different libraries provide them, and they basically can do anything. So what they do is at compile time, they change your case class definition if needed. They change your companion objects for sure, and they can interact in weird ways. So I have like 6 different generic derivation annotations in Circe. Other libraries have generic derivation annotations, and you throw them all together and maybe they're going to do something weird. This is a much more principled way where the author of each of these type classes can say, okay, here's how I want things to be derived, and I don't have to worry about those clashes between, that I would often see between macro annotations. Okay. And just to quickly look at what that looks like, okay. So this is is that large enough to see? Bigger? Okay, yeah. So I won't have time to go through this in detail, but basically there's this, any method that has an inline derived signature, if you name this method derived, and your user writes derives your type class, it will try to, at compile time, use this implementation to provide a type class instance of that case class or that ADT that you're defining. And the process here looks a little bit different from the way that you would do it in Shapeless, but the idea is almost exactly the same. That what I'm doing is I'm saying if what I have is a product, something like an something that can be represented by a tuple or an H-list, then I'm going to go down this route. If I did support ADTs, which I don't for monoid, but for encoders and other things I do, then there would also be a sum case here. And then you have this new syntax with the star and the colon, which is kind of like an H-list, but it's just a representation that the compiler is aware of a tuple. And you build these instances up inductively in the same way as you would with Shapeless, that you have first an instance for just HNIL or unit, and then you have an instance for each of these additional elements in your type level list that is the generic representation of your case class. There are some things that kind of frustrate me here, like there's a lot more casting than I'd like, but in general, it's a pretty clear, much nicer way of doing this than what we have in Circe right now. Okay, any questions before? Sorry, yes?
Is that thing verified at pre-runtime in the same way that, or is it done at runtime in the same way that your inductive ones were in Scala 2?
No, so yes, that's a good question. So it's much better at erasing the representation at runtime. So in that there is a lot of overhead in Scala 2 when you do use this mapping to the generic representation and then back to your own representation that just doesn't exist here in the same way. There is still some runtime overhead. I meant to do some runtime benchmarking of these things, but I just haven't gotten around to it yet. But I think it'll be interesting to see how they compare to handwritten instances and Scala 2 instances. Mm-hmm. Okay. So the next thing I want to talk about is the macro system. So in Scala 2, you just have so much freedom with the macro system to basically take expressions, type check them arbitrarily, just like do random stuff, throw a bunch of expressions together into some kind of tree, and then ask the compiler to compile it. And that can be really nice when you're doing something like a JSON interpolator. So right now, Circe provides this compile time JSON interpolator where you can just stick this thing on the front of your string, and then you write arbitrary Scala code in interpolated blocks inside your string. And what will happen is at compile time, it will break the string apart. It'll look at each one of these blocks. It will type check them. It will replace them with these unique identifiers that it's made sure don't exist anywhere else in the string. And then while it's parsing this thing, it's building up a JSON expression and plugging in these encoder calls for each of the interpolated expressions. And what I get in the end is just a blob of Scala code, and then it hands itself off to another part of the compiler and says, hey, try to compile this. And if it compiles, then this thing turns into a big expression that builds a JSON value at compile time. Most of that stuff is no longer possible with the Dotty macro system, at least in terms of the parts that are possible for me to understand. So you have a much more limited API. You can't do this kind of arbitrary type checking or arbitrary building up expressions and trying to get it to compile. So with a little fussing, I was able to get something that's almost feature equivalent. So instead of just taking these things and type checking them and then asking for encoders of each of those types, what I'm doing is having as a separate step this kind of magnet patternish thing where I take each of these values and convert it into this as JSON wrapper. Do the same parsing step, and insert the JSON values into the JSON result. And for the most part, it works. It does require implicit conversion, so you need this extra language import, and it doesn't support interpolation into key positions. And I can't really think of a way using the parts of the macro system that I understand right now to support key interpolation. So in Scala 2 right now, I can interpolate variables into either value positions in my JSON or into key positions. But what that requires me to be able to do is to just replace those expressions with a key encoder apply call or an encoder apply call as needed at compile time based on the position. And I just don't see a way to do that in Circe yet. I mean, in Dotty yet. Okay. Let's see. Okay. Are there any questions about the macro system? So the macro system is the part of this thing that seems to be changing the most quickly. So since I started working on these macros a week and a half ago, I've had to change things a couple of times. And it's the part that I don't really understand very deeply. So it's something I want to spend more time with. But right now, I just don't see, it doesn't seem like it's going to support a lot of things that I have macros that work in Scala 2. Okay, so this is another feature that I'm really excited about in Dotty. So how many people use value classes in Scala 2? how many people feel like they have a really good sense of when your value classes are actually getting boxed when you don't? Oh, you do. You raise your hand. Okay. So Dale does have a good sense of it. I know I absolutely don't. That I feel like I basically just suspect that if I put something in a value class, it's going to be boxed, and I don't really know what kinds of advantages I'm getting for it, but I just do it anyway. Opaque types are a totally different approach to the same pattern. So with value classes in Scala 2, as soon as you put them into a list or into a generic container, they're going to be boxed, and you're going to pay the full price of a case class or an ordinary class. That's not the case for opaque types. So they're an attempt to solve the problem the value class has solved, but in a way that doesn't have the same kind of runtime overhead for a lot of standard use cases. This is a kind of minimized example. So I've used value class or opaque types in a few places in the port so far, but I've taken one of the types from Cat's data, the nonempty chain type, and I've re-implemented it using opaque types. So it looks a lot like a type alias in Scala 2 or in Dotty. What we're doing is we're saying that within the scope of this file, it seems like, I can't remember at this point if it only includes the companion object or if it includes the whole file. So that seems like a point of debate right now. But within this file, chain and nonempty chain are the same. So I can do things like, this is just a type alias, as you would use a type alias in Scala 2. So if I have this toChain method, I can just return a that returns a chain. I can return a nonempty chain, and it compiles just fine because within this scope, this is just an alias for chain of A. But then outside of this unit, that aliasing is not visible. So to the outside world, I don't have this equivalence between nonempty chain and chain. So I can't just take a chain and treat it as a nonempty chain, that these are two entirely separate types. I have to use the conversions that I define in this file. So this allows me to build a chain from a nonempty chain from a chain if I know that it's nonempty. This allows me to go in the opposite direction, but these are the only ways that I can map between the two from the outside world. So within this file, they're the same. It's a type alias. Outside this file, they are unrelated. So it's a very different approach from value classes. It seems like it solves a lot of the problems that we've had with value classes. Some things are kind of weird about it. So it becomes really difficult when you're writing these things to, if you have a bunch of type class instances for chain, for example, and I want to define a bunch of type classes instances for nonempty chain, if I try to resolve something like a traverse of chain, inside the definition of a traverse for nonempty chain is just going to resolve itself because that's just, I'm not going to actually see the outside instance for chain. So you run into problems where you actually, it seems like, at least as far as I understand it so far, you have to go out and give a name to the instance for chain of traverse or whatever so that you can refer to it here. Because if you just try to resolve a traverse chain in this scope, you're going to get the traverse nonempty chain that you're defining. Also, I would really love to be able to use derives clauses on these things in the way that you can with new types in Haskell. That doesn't seem like that's supported at all at this point. But it's a huge improvement over the value class experience. Yes? Does it have the same boxing behavior as any? No. So I can make a list of nonempty chains, and they will not. So the question was whether it has the same boxing behavior. Yeah. So a list of these, an option of these, isn't forced to box in the same way that it would be with value classes. Yeah.
And what if you have two of them, like a nest? Because at the moment, if you have like an anyval with an anyval, it also boxes. Is it the same here? If you have an opaque type with an opaque type?
I don't know. We should try it out, but I don't think it will. It shouldn't have to box. Yeah. Okay. So any questions before we look at my long list of complaints about this? Yeah, so when I first started playing with this, I like the very first day I started working on this port, I ran into like 4 issues with extension methods, and so I opened a couple of issues against the Dotty issue tracker, and like within literally 2 hours, the 2 issues that I opened on that first day were fixed, and then in the next nightly, I was able to use those fixes. So even though I've run into a lot of issues as I've been working on this stuff, it's the compiler team, or the team, is really responsive and is doing a great job of helping get these things resolved. But some of these are, let me see. Let's see. Has anybody else played with Dotty? Have you run into pain points? Has anybody written a line of Dotty? Okay, so a couple of people. But there's some really nice things like now traits can have constructor parameters, and they can have given parameters, which is really cool. That for all of the laws in Cats laws, I was able to do a ton of simplification, because now instead of having to just like, because traits in Scala 2 don't have parameters, I have to have these members inside of each trait that collects the type level, or the type class instances that law package needs. Now I can just stick those on as given parameters. And because traits can now have either constructor parameters or given parameters. The thing that sucks is that these will not be applied automatically when I instantiate the trait. I have to actually list out every single super trait so that the necessary given parameters will be applied. So there are lots of little things like this that I think make the experience a little less great than it could be, but it's still just a much better experience in so many ways than working in Scala 2. Okay. Some of these other things, like I've not been able to get a single enumeration implementation to work. So I'll take something like the comparison case ADT in Cat's kernel, and it's like a very clear instance of something that would make a good enumeration in Dotty. And I do like the most vanilla port from the ADT to enumerations, and I get like these weird no such field errors somewhere. So there are a lot of things like this that I need to minimize and actually open as issues that I don't understand right now. But they're relatively rare. That a huge part of this code base is now idiomatic Dotty, is much cleaner, much nicer to work with. And works perfectly. So I guess I could go on complaining, but it would probably be more interesting for me to answer any questions you have. So thank you.
Thanks for the talk. That's very interesting. One of the points that people complain a lot about Scala 2 is the compiler speed. So have you noticed improvements in Dotty on that compiler speed, and how much faster roughly are we looking at, if anything?
I have not. So the generic derivation is definitely faster. I meant to have some, so I have some projects that just include a bunch of code-gen case classes that I use as like my standard generic derivation test suite for Circe projects. I've played around a little bit with trying to use that with Dotty's generic derivation, but I don't have good numbers yet. But that's something that it's next on my list of things to do. Just the experience feels not slower and faster in some ways.
Okay, great, thanks.
Yeah.
Thank you for the talk. So one of the pain points that I have with Scala 2 is the difficulty of debugging implicit resolution. Quite often I'll probably be doing something pretty complicated, but then I'll have to go down to the level where I'm logging implicits and trying to scroll through the compiler logs and figure out what's going on. Is this significantly easier with Dotty?
It is. So we can look at You will get a nice breakdown that will say, and have you ever used anyone the Splain plugin for Scala 2? So this is a compiler plugin that tries to make failures of implicit resolution more readable. You get something that's kind of similar to that experience, where it will say, here are the implicit search that I was doing when I failed. Here's what I was looking for. Here's my hypothesis about why this didn't work. So I think it's still kind of rough that and if you are using these anonymous type class instance definitions, you are going to see a bunch of synthetic stuff in there. Still, I assume that's not going to be the case in any in future versions of Dotty, but it is a better experience. Yeah.
Okay. There's no, I guess there's no option to call well, I guess in Scala 2 it would be an implicit function explicitly. I guess there's no option to do that with the given derivations.
You can ask for I mean, this is what the method will. You can use the to resolve an instance, and you can also pass a given explicitly if you need to. So it doesn't look like. Yeah, that's a good question. That there are a number of places in the code base, like parallel, where here we. I haven't done a full port of parallel yet, but in a lot of cases, I need to apply a given instance explicitly. So I just have this, instead of just tacking on another parameter section at the end, you have the given keyword is used in this place as well. So after the non-explicit parameter sections, you would have given and then the instance that you're passing to the method that has the constraint. So you can, through some combination of the and these given, passing givens explicitly, at least I haven't run into any cases where the anonymousness makes that difficult.
Okay, thanks.
Mm-hmm.
Have you experimented with a new type for the monoid of Boolean or something like this?
Do you mean so that I can have multiple?
Like a monoid for and a monoid for all?
Right. I mean, you can do it. I have a different type class instance for nonempty chain than I do for ordinary chain. So you can have instances for any opaque type that are different from the underlying type. Yeah. Yes.
I vaguely remember one question about dropping the new keywords in Scala3. Has something landed in Dotty around that part?
What?
There was some conversation on the Discord channel where they were talking about dropping a new keyboard for constructor. New.
Oh, the new keyword. Yes.
They were talking about dropping the new keyboard for constructor.
Right.
I was asking if has something made it to Dotty on that part, or is it still in Generalpurpose?
Yes. So I haven't used this in many places, but the new keyword is no longer required to call a class constructor. Yeah. I don't know how I feel about that. It seems like I think that having this distinction between ordinary constructors and the kind of safe constructors that you would define in a companion object, I've always liked that distinction. So when I heard that the new keyword is no longer necessary in Dotty, I was kind of skeptical, but it does work. I have tried it. You'll see it in the code base if you look. Yeah.
Thank you very much for the talk. It was quite interesting. I have a few questions. One of them is a bit Cats specific. One of the things on the design of in the writing on the code of Cats is that they include some patterns just to work around some limitations of Scala 2.
Yes.
For instance, one of them is that when you have for the same data type, if you have the hierarchy you were showing before, the hierarchy of type classes, that for a type you want to define an instance of functor or applicative or monad or whatever,
yes,
and any of those instances requires less, what you have in Cats is like they create, the only way in which they can avoid incompatibility is by creating priority,
yes,
artificially by using this kind of wrapper traits.
Right.
Is that something that the Dotty or the implicit system of Dotty allows you to bypass, or to introduce priorities between implicits when you have the implicits being for subtyping of the...
Right. No, you do still
Maybe an
need...
example will help.
So yeah, one example would be, so in the current version of this experiment, so I mentioned that I'm moving the type class instances for standard library types into the roots of this type class forest, so that they will be found automatically by implicit search in implicit scope. But you do still need to do some prioritization. So let me open. Wait, that's the wrong ink. No, we'll look at semigroup. So it is still necessary to have these multiple levels of traits to force prioritization. That was something that I was wondering about, and maybe it's something that will be possible to do in a nicer way in the future. Yeah.
The second question about Cats specific, and because you mentioned before type lambdas, this partial application pattern in which you have like a constructor or some of method in which you have to inject one type, and when you pass one type or the value, for instance, or
right.
we're fixing a type, you are going actually to create another factory that you then apply
right.
again. Is that something that also Dotty can remove? Or
yeah,
still?
that's a good question. I think that I'm trying to think of.
I think that the IDT has a few examples of that if
right.
somebody doesn't know what I'm
right. So
talking
the question is about these partially applied classes in cats, where sometimes we'll want to have some type parameters applied explicitly and some type parameters not applied or inferred. So you can actually have named type parameters in Dotty right now. So you could just say it should be possible if you don't mind naming them, but it's not going to work positionally in the same way that it works in cats right now. So you're not going to get exactly the same usage as you have in cats with these partially applied class things, because you will have to name the type parameter that you want to supply. But there is you can name these things and let the rest be inferred.
One last question, but that's because I was curious. Do opaque types still include all of the methods from the any type, from the top type?
Yeah.
Or are they defined without methods, without any method altogether?
I don't know. You should look at the documentation about this. That what is it? So you're going to get the toString from the underlying type and some stuff like that. That's something that we could try it out afterwards. Take a look at what happens in those cases.
Thank you.
Mm-hmm.
Yeah, so I'm not sure how involved you were in sort of the whole Dotty process, but
I complain about stuff. That's
excellent. Yeah, so what you're sort of trying to do with Dotty, the way you've sort of taken Scala 2, where you've got language features that have been abused to create something, and then sort of internalize those into a language, reminds me a lot of what people were trying to do with C++11. And C++11 famously was, I think, supposed to be C++07. It came in 4 years late, and they're still trying to fix it. So I'm sort of, what you're sort of saying now, it seems like Dotty's gone quite smoothly, even though you're sort of addressing the same challenges. So I'm sort of wondering how you've managed to avoid the elephant traps that C++ managed to fall into pretty much every one of them. But how's it sort of gone that smoothly compared to the C++ process that was trying to do the same thing?
Right. I think the ideal person to answer this question would be somebody who didn't seriously look at Dotty only 2 weeks ago. But my impression, just as I've been working on this experiment, is that the fact that you basically have all of the features of Scala 2 to fall back on makes a really comfortable space to work on stripping things out. So you can start with this really minimal feature set for these new given constructions, because when they don't work, you can fall back to just ordinary implicit definitions, and that because Dotty as Scala 3 is years out, we have a lot of time to, and that's part of the point of this kind of experiment, is to get a sense of what the limitations are with the current constructions, find out if there's things that I personally, as a library author, want to advocate for to make sure will be possible in Dotty, but we have a lot of time to do that. I wish we had people from the Dotty team here to answer the question about how to avoid these pitfalls, but I'm optimistic right now. And it's kind of bizarrely surprising to me how well the Scala 2 interop works. That if we're just thinking about, a lot of people have had fears that we're going to have a situation like the Python 2 to Python 3 situation where a large part of the community just doesn't upgrade because the changes are so substantial. But the fact that you can just take arbitrary Scala 2 artifacts actually makes, in a lot of ways, this process of porting something to Dotty easier than the process of adding 2.13 support to a 2.12 library. That in that case, you have to do all this work to wrangle your dependencies. There are just a lot of issues that if you can just bring in arbitrary Scala 2 artifacts and expect them to more or less work in Dotty, it makes this at least I'm optimistic that this process of migration might go more smoothly.